Hi all, welcome back to Malware Analysis. I am Jay Lavanya, Assistant Professor of CS Department. So today in this video, we are going to discuss the topic called Unit 3. In that, Disassemblers, Debuggers and Decompilers. Let's dive into the topic. Okay, so first topic is that Disassembler. So Disassembler is a computer program that translates the mission language or the mission code, that is binary language, into an assembly language. Assembly language, it is a human readable representation of the mission instructions that a processor executes. So it provides a comparative overview of disassembler, debugger, and decompiler. These three essential tools, that is, as I told earlier, this is assembler, debugger, and decompiler. It's the realm of reverse engineering and software analysis. So we will just discuss about the strengths and limitations and understanding these tools, right? So this disassembler are essential for understanding the inner workings of a compiled programs, especially when source code is unavailable. Okay, and it is crucial for reverse engineering, which allows the user to understand how a program works by analyzing its underlying code. So what are the key aspects of disassembler? If you take the first one, conversion. Okay, so disassembler take the mission code as an input and output assembly language code. And second one, that is reverse engineering. They are fundamental tools for analyzing and understanding the functionality of the software, particularly when the source code is unavailable. And next one, human readability. The output of a disassembler is formatted for human readability, making it easier to analyze and interpret. And next one, like applications. So disassemblers are used in various fields, including first one, malware analysis, that is studying some malicious software to understand its behavior and to identify some potential threats. And second one, like software modification, making changes to software by patching some binaries. And next one, recovering the lost source code, that is reconstructing the source code from the compiled binaries. And next one, like compiler analysis, so examining the output of compilers to understand how they optimize the code. Okay, so next topic, that is the functionality of the disassembler, right? The primary function of a disassembler, uh, is to take a binary file as an input and output the corresponding assembly code. So this process involves the first one, identifying the instruction, second one, decoding the instruction, third one, generating the assembly code, and fourth one, that is handling the data. So first one, identifying the instruction. The disassembler analyzes the binary file to identify the start and end of each instruction. So this is done by recognizing the opcodes that define the type of instruction and decoding instruction, second one. So once an instruction is identified, the disassembler decodes it to determine the operation being performed and the operands involved, like the operands like registers, memory addresses, or the immediate values. And next one, that is generating the assembly code. So the disassembler then generates the corresponding assembly language representation of the instruction using some mnemonics like short and maybe some symbolic names like add or sub, like multiply, mul, or something like that. Okay, for the opcodes and appropriate syntax for the operands. And next one, like handling data. So for handling data, disassemblers also need to differentiate between the code and data within the binary file. So they typically use some heuristics and analysis the techniques to identify the data sections and represent them appropriately in the output. And what are the use cases if you take? So disassemblers are used in various scenarios, including the first one, reverse engineering. Let's analyze the functionality of a program without access to it, some source code. And second one, like vulnerability research. So identifying the potential security flaws in the software by examining the assembly code for the vulnerabilities like the buffer overflow or format string bugs. And next one, like malware analysis, understanding the behavior of malicious software by disassembling its code and analyzing its actions. And software compatibility, and like analyzing the assembly code of a program to determine its compatibility without like different hardware or by using some operating system. And debugging. So while debuggers are generally preferred for debugging, assemblers can be useful for examining code at a very low level, especially when dealing with some optimized or with obfuscated code. Okay. Next, we are going to discuss is about the limitations of disassembler. First one, complexity. So assembly code can be complex and difficult to understand, especially for the larger programs. So abstraction, like disassemblers provide a low-level view of the code, which can make it difficult to understand the overall program logic. And third one, like obfuscation, techniques like code obfuscation can make it very difficult for the disassemblers to accurately translate the binary code into the assembly language. And next one, like architecture specific. So the assemblers are typically designed for some specific processor architecture. Example x86 or ARM. So a disassembler for one architecture cannot be used to disassemble the code for the another architecture. So the popular examples like in Disassemblers IDA Pro or OLEDBG and Capstone. Okay, so all those things comes under this disassembler. And apart from that, there is some list of disassembler like IDA or Binary Ninja, GNU Debugger, and Radar 2 as well as Hopper. So IDA is an interactive disassembler which is capable of disassembling like virtually any popular file format, and this makes it very useful to some security researchers and CTF players who often need to analyze obscure files without knowing what they are or where they come from. And IDA features the Hex-rays decompiler which can convert the assembly code back into a pseudocode like format. Okay. So, and it's like Binary Ninja. So, it is also an interactive decompiler, disassembler, debugger, and a binary analysis platform. But it's less popular or as old as IDA. This Binary Ninja is often called as Binja, which is gaining some ground and growing community of some dedicated users as well as some followers. And this Binary Ninja also features some decompilation for all the architectures, which can convert the assembly code back into a pseudocode like format, represented as a higher level that is IL pseudo C, pseudo Rust, pseudo Python, or your own using the Python, C++, or the Rust plugin API. And next one like GDB. So the GNU debugger is a free and open source debugger which also disassembles the programs. It's capable as a disassembler, but most notably it is used by the CTF players for its debugging and dynamic analysis capabilities. Okay, so all those things comes under the disassembler. And the next one we are going to discuss is about the debugger. So what is mean by debugger? Yeah, so this debugger, it is also a tool that is used to test some and debug the software, and it allows the programmers to step through the code execution, examine the variables and set some breakpoints to identify and fix the errors. Okay, and what are its functionality? The first one, breakpoint setting, second one stepping, third one variable inspection, fourth one memory inspection, and fifth one that is called stack analysis, right? So these debuggers provides a range of functionalities, including the breakpoint setting, which allows the user to pass the program execution at some specific points in the code. And second one, like stepping, it allows the user to execute the code one inspection or line at a time. And third one, like variable inspection, which allows the user to examine the values of variables and registers during the execution. The next one, like memory inspection, it allows the user to view the contents of memory locations. And next one, like call stack analysis, it allows the user to trace the sequence of function calls that led to the current point of execution. And fifth one, like conditional breakpoints, it allows the user to set some breakpoints that are triggered only some certain conditions are met. Okay. And if you take what are the use cases, it's essential for finding and fixing bugs, like identifying and correcting errors in the software code. And next one, like understanding the program behavior, gaining insights into how a program works by observing its execution and reverse engineering. So debuggers can be used in conjunction with some disassemblers to understand the behavior of the compiled programs, and performance analysis, identifying the performance bottlenecks in software by observing some execution time. Okay. And apart from that, so this debuggers, right, it is mainly provides features like setting breakpoints, stepping to the code, all these things. But if you take this, how this debuggers help is that they are invaluable for finding the root cause of the errors. So by stepping through the code and inspecting the variables, you can trace the execution path of the program and identify the exact line where an error occurs. And second one, like understanding the program behavior. So debuggers allows you to observe the program state in real time, which helps in understanding how it works and identifying the unintended behavior. And third one, like testing the code. So debuggers can be used to test the different scenarios and ensure that the code behaves as expected. Okay. So like example, I just say, so imagine a program that calculates the average of a list of numbers. So if the program is producing some incorrect results, you can use a debugger to set a breakpoint at the beginning of the averaging calculation, or you can step through the code, absorbing the values of the list elements, the sum and the final average. And third one, you might notice that a sum is being calculated incorrectly, or that the final division is being done with the wrong divisor. So this would help you pinpoint the exact location of the bug as well as correct it. Okay. So the in debugger also we have some debugger UI and debug protocol, and there will be some adapters like mono debug, mock debug, your debug. So like VB protocol will be using these kind of nodes to debug in the setting, the breakpoints and all those stuff, right? So these all comes under the functionality of debuggers. And next one, let's see about the limitations of the debugger. Okay. So first one, source code dependency. Third, second one, like complexity. Third one, obfuscation, and fourth one, like dynamic analysis. So source code dependency. So debuggers typically work best when source code is available, as this allows the users to step through the code at a higher level of abstraction. And second one, like complexity. So debugging complex programs can be challenging, especially when dealing with some multi-threaded or distributed systems. And third one, like obfuscation. Code obfuscation can make it difficult to debug the programs, as it can hide the true program logic. And fourth one, like dynamic analysis. Debuggers primarily focus on dynamic analysis, which means they can only identify the errors that occur during the program execution. And static analysis tools are needed to identify the errors that may not be triggered during the testing. Okay, so these are the limitations of debuggers. And next topic is that decompilers. Okay, so decompiler, it's a computer program that attempts to translate or the mission code, that is binary language, the higher level programming languages to C, C++ or Java. And decompilers aims to reverse the compilation process or making the code more understandable and easier to analyze. Okay. And apart from that, this decompiler, what it does is that so it is or useful for understanding functionality of the existing software, debugging and recovering the lost source code. However, due to the nature of compilation and optimization, decompilers typically don't produce perfect recreation of the original source code. So how this decompilers work is that so reverse engineer compilation, like the compilers take the compiled code, often in the form of mission code or bytecode, and attempt to reconstruct the original source code. And second one, like high level language output. The output of a decompiler is typically a high level programming language that a programmer can understand and potentially recompile. And third one, like limitations, due to the optimizations and other transformations performed during compilation, decompilers often produce a code that is not identical to the original source code. So this can include things like obfuscation or removal of comments and the changes to the variable names. Okay. And next one, like reverse engineering tool. So this decompilers are crucial tool in reverse engineering, which allowing the users to analyze and understand the inner workings of the software. Okay. And next one, the use cases for the decompilers. Debugging, that is decompilers help the developers debug the third-party libraries or the applications where they don't have access to the original source code. And second one, like code understanding. They allow developers to analyze and understand the logic of existing software, even if the original source code is unavailable. And third one, like recovering the lost code. So in some cases, decompilers can be used to recover the lost source code from compiled files. And next one is security analysis. Decompilers are used to analyze the functionality of malware and other malicious software. The next one, like research and development. Researchers use the decompilers to study compilation techniques and develop new decompilation algorithms. Okay. And what are the examples of decompilers? If you take like ILSpy, that is a popular open source decompiler for .NET applications. And second one, like IDA Pro with some hex-rays decompiler. That is a powerful commercial tool for disassembling and decompiling a wide range of code. And third one, that is GDA, that is Android decompiler, a decompiler that's specifically designed for some Android applications. And next one, like a .NET Reflector. It is also another popular tool for decompiling .NET code. And next one, the JEB, that is Java Decompiler. That is a commercial decompiler for Java and other languages. Okay. So this is an intro of the decompiler. So next is that functionality of the decompiler. So the primary function of a decompiler is to take a binary file as input and output the corresponding source code in a higher level language. So this process involves first one, disassembly, second one, control flow analysis, third one, data flow analysis, and fourth one, like code generation. Okay. And so first one, that is disassembly. The decompiler first disassembles the binary code into an assembly language, and control flow analysis, The decompiler analyzes the assembly code to identify the control flow structures such as loops, conditional statements, and function calls. Third one, that is data flow analysis. The decompiler analyzes assembly code to track the flow of data through the program or identifying the variables, data structures, and their relationships. And next one, the code generation. The decompiler then generates the corresponding source code in a higher level language using the information gathered from the control flow and data flow analysis. And next one, like another functionality is that is like optimization. So some decompilers perform some optimizations to improve the readability and accuracy of the generated code. Okay, so these are the functionality of the decompilers. And next one, like use cases, if you see, decompilers are used in a variety of scenarios, like including first one, reverse engineering. So understanding the functionality of a program without access to its source code. And next, decompilers provide a higher level of abstraction than the disassemblers, making it easier to understand the overall program logic. And second one, like vulnerability research. So identifying some potential security flaws in software by examining the decompiled code for the vulnerabilities. Third one, like software porting, supporting the software from one platform to another by decompiling the code and then recompiling it for the new platform. And next one, like code recovery, recovering lost or damaged source code by decompiling the binary code. Okay, so these are the functionality of the decompilers. Next one, we will see about the limitations of the decompilers. So limitation first, like accuracy. Decompilers cannot always perfectly reconstruct the original source code. The generated code may be different from the original code in terms of variable names, comments, and code formatting. Second one, that is complexity. Decompilation, it is a complex process, and decompilers can struggle with some highly optimized or with some obfuscated code. Third one, like information loss. The compilation process involves information loss such as variable names and comments, which cannot be recovered by the decompilers. Next one, like language specific. So decompilers are typically designed for some specific target language, example C or the Java. So a decompiler for one language cannot be used to decompile the code into the another language. And next one, there is another limitation like legal issues. So decompiling the software without the permission may be illegal in some jurisdiction. Okay, so these are the limitations of the decompilers. And next we'll discuss about the disassembler versus debugger versus the decompiler. Okay, so first, if you take the characteristics of disassembler debugger, the input for assembler is a binary code, and the input for the debugger, which will be of executable program, and the input for the decompiler is a binary code. Okay, and output for the disassembler will be assembly language, and for the debugger you have the program state as well as the variable values, and for decompiler the output will be of high level language, right? But the abstraction level for disassembler will be low, debugger will be medium, and for decompiler it will be high. Okay, and use cases we have discussed already. uh, this disassembler is used in some reverse engineering or the malware analysis, and second one like bug fixing and program understanding. And decompiler is also used in reverse engineering and code recovery. And strength, if you take for disassembler, it provides a detailed low level code view, and for debugger, it allows the dynamic analysis and code stepping, right? And for decompiler, it provides a higher level of understanding. And the limitations, if you take for disassembler, Assembly code can be complex and difficult, right? And for debugger, it requires a source code for some optimal debugging. And as well as for decompiler, if you take the limitations, the accuracy can be limited and there will be some information loss. Okay, so these are the differences between the assembler, debugger, as well as the decompiler. Okay, so in this particular video, we have discussed about the assembler, debugger, as well as decompiler. So what are this definition and what is this functionality? What are the real-time examples and use cases we have discussed for each and every thing? I hope and last in the last slide we have discussed about the differences between these three things. I hope this video will be very useful for you. We will see you in the next video. So do like and subscribe to this channel. Thank you all.